We'll start by reviewing some of the things we talked about in class. The summary of how the division algorithm works is that you really need to make sure to focus on the r. The remainder has to satisfy this inequality. 0 is less than or equal to r, which is less than the absolute value of a. And we say absolute value of a because sometimes we want to divide by a negative number. Okay, so the best way to do a division algorithm problem is to divide absolute value of b by absolute value of a, and then adjust the q to make the remainder land where it needs to land. So here's an example of me not doing that properly. If I do negative 17 divided by negative 3, and I want to write it in the form b equals aq plus r, I could just do 17 divided by 3 and get that negative 17 is negative 3 times 5 plus 2. I could just take this 5 and this 2 and just copy them here. But if you actually calculate this right-hand side, you're not going to get the correct answer. You're not going to get negative 17. So you need to think, okay, what does the q need to be in order for me to get negative 17 on the right-hand side? Well, let's say I make it negative 5 instead of positive 5. Well, that's worse. Now I have positive 17 on the right-hand side. I'm even further from what I need to be. So maybe what I need is to change my q in a different way. I need a number that's more negative than what I had over here. Because over here, the right-hand side ended up being negative 15 plus 2, which is negative 13. That wasn't negative enough, which means I need a bigger negative number here. So I'm going to choose 6 as the number I multiply by the a, which is the negative 3. And what we have so far is we have negative 3 times 6, which is negative 18. To make that into negative 17, I just have to add 1. And now my r is satisfying the inequality it's supposed to satisfy. 1 is between 0 and absolute value of negative 3. Recall we also talked about some binary operators called div and mod. So b div a is the q you get from the division algorithm, and b mod a is going to be the r that you get. Remember, there's these restrictions on r. R is always going to be non-negative, and it's always going to be less than absolute value of a. We went over this example in our class session, but based on the chart that's over here, we have the following answers for these div and mod questions. Now go ahead and try hands-on exercise 5.2.2 if you haven't already done so. Pause the video and then come back. Okay, hopefully you had a chance to try those and you checked them and made sure that they made sense. This example is a little bit more elaborate. It's saying, let n be an integer such that n div 6 is q and n mod 6 is 4. Let's translate what that means using the definition of div and mod. N div 6 is the quotient you get when you divide n by 6. So we have n equals 6q plus r. And they called that quotient q, so what I've written here is consistent with what they're giving in the problem. What about the mod? N mod 6 is the remainder we get when we divide n by 6. So this is saying, and I'll write it in words, the remainder when dividing n by 6 is 4. The remainder is 4. The remainder is 4. That means we can write a renewed equation, n equals 6q plus 4. We're not done with the problem. I shouldn't put a box around it, but this is just preliminary thought process before we continue reading the problem to figure out what they're asking for. So with this notion that n equals 6q plus 4 in this problem, we continue. Determine the values of 2n plus 5 div 6 and 2n plus 5 mod 6. So what they're asking is, what is the quotient, the q in the division algorithm, when 2n plus 5 is divided by 6. That's this part. And the second question is, what is the remainder? Again, the r in the division algorithm. I'll often abbreviate division algorithm div-alg when 2n plus 5 is divided by 6. So here's the solution to that problem. I'll keep it in view while we examine the solution from the text. So as we deduced while reading the problem, the given information implies that n equals 6q plus 4, where q is, of course, an integer. What does 2n plus 5 look like? Well, I can plug in this expression for n in 2n plus 5, which means I get 2 times the quantity 6q plus 4 plus 5, which if I simplify that, I get 12q plus 13. And what I want to be able to do is I want to write that in the form 6 something plus something. I want to write it in that form such that this something over here, the r, is between, let's do a different style box just so we don't mix it up with the first box. 0 less than or equal to TV box, less than absolute value of 6. Okay, because as we talked about when we reviewed long division, the remainder always has to be less than the divisor, and it always has to be non-negative, which means 0 or positive. Okay, so the way they chose to factor it is 6 times 2q plus 2 plus 1. So if the algebra there isn't making sense, we can look at that a little more. So 12q plus 13, well, that's the same as 12q plus 12 plus 1. And I did that because I noticed I would get a common factor of 12, but I don't really care about a common factor of 12. I care more about a common factor of 6, which is why I get 6 times 2q plus 2 plus 1. The solution to this example continues to say, therefore, 2n plus 5 div 6 is what we got here, which was the 2q plus 2. And the 2n plus 5 mod 6, 2n plus 5 mod 6 is going to equal 1. It's going to equal this 1 that we got. With that example in mind, go ahead and try this hands-on exercise before joining me for the next video.